Hello and welcome to the course of Design of Machine Elements 1. In a previous video, since we have been gone through like what are the design consideration, what are the standards we need to follow, what is the factor of safety, all this. So in this video, an attempt is made to understand or to solve the case, if at all, how to determine a plane stresses with a two-dimensional element. So for which I will be considering one example. As you can see this, there's an example. The state of stress at a point in a strained metal is as shown in figure. There's a two-dimensional element which has a stress at sigma x and sigma y, over which the sigma x is 180 Newton per mm square and sigma x is 120 Newton per mm square, and we have one shear stress over it 80 Newton per mm square, which will be tau xy will be equal to tau yx, and tau in the similar way it's over here, tau xy is equal to tau x, which is about 80 Newton per m square. So all the way you need to find out what is the direction of a principal stress, magnitude of a principal stress, and the magnitude of the maximum shear stress and its direction. Let's see how we do it. So first let's sort out the given. So this is the one element which has been given to us in order to find the parameters. So for which to find would be the direction of plane, principal planes, which is phi, and the direction of principal stresses sigma 1 and sigma 2. The magnitude and sigma maximum shear stress in its direction, tau max and phi s. So kindly note that in order to solve all the cases in this course Design of Machine Elements, I will be referring up a data handbook 3rd edition by Badhavan and Balavi Reddy. So first step, what we do is, as usual, there is an element. First thing is the direction of principal planes, for which I will be choosing up the equation. As you can see over here, tan 2 phi equation, which is of 1.9. So for page number 2, in a similar way, I call upon that one. So where tan 2 phi is equal to 2 tau xy divided by sigma x minus sigma y, which is of 1.9 equation, page number 2. You want to mention this. So since tau xy is 80 Newton per mm square and sigma x is 180 Newton per mm square and sigma y is equal to 120 Newton per mm square. Now substituting everything, all the values in this above equation, the answer what we get is 2 phi is equal to 69.4 degree and 69.4 plus 180 degree in an opposite one more plane. So for which the phi would be 37.72 degree and 124 degree. In the next procedure, next step, for same element we need to determine the magnitude of a principal stress. So for which again, for this maximum minimum plane stress on need to be determined. So first one, in order to find out the maximum principal stress, as usual, page number 2, I will be referring this equation 1.11a, which says the maximum principal stress, and the equation says sigma 1 is equal to sigma x plus sigma y divided by 2 plus root of sigma x minus sigma y by 2 whole square plus of tau xy whole square, which is of equation 1.11a of page number 2. Now you know the values again, sigma x, sigma y and tau xy. Now substituting everything in the above equation, the answer what we get, sigma 1, which is a minimum principal, would be 235.44 Newton per mm square. Now followed with and you know that since it's in a plus, we don't have any a negative sign over here, so we consider this as the whole system is under tensile. So in a similar way, further in order to find a minimum principal stresses, so I going to choose again a equation over here, which is of 1.11b of page number 2. Then I'm drawing up the formula over here, sigma 2 is equal to sigma x sigma y divided by 2 minus of sigma x minus sigma y whole by 2 into whole square plus of tau xy. Now again considering all the values, you know all the values given over here in the element. So substituting in this equation, the value what I got would be 64.5 Newton per mm square. So in further, since it's a plus y, it doesn't have any minus sign over here, so we consider this stress would be in tensile in nature. So the next step would be, in order to find out what would be the magnitude of the maximum shear stress and its direction. So in order to find out the maximum shear stress, I do again follow up with the same page number 2 with the equation where the equation says tau max is equal to plus or minus root of sigma x minus sigma y divided by 2 whole square plus of tau xy, which is of equation 1.12 of page number 2. Now substituting all the values, as you know very well, which have been given over here. Now substituting into this, what I got is plus or minus 85.44 Newton per mm square. So next would be, in order to find out the direction of that, in a similar way, I going to again choose the formula from a data handbook which is given over here. As you could see here, 2 tan phi s and I will be sharing up the same formula on the screen right over here. Now this 2 tan phi s is equal to sigma x minus sigma y divided by 2 tau xy, which is of equation 1.10 of page number 2. Now again substituting all the values, so whatever the phi s that I get over here would be in a two-way. One is a 20.5 and another one 20.5 plus 8, so which would be 10.25 degree and 100.25 degree. So this is a way how to find a stresses of principal, minimum, magnitude and direction when a simple plane is given to us, a two-dimensional plane is given to us. So I'll be adding up one assignment here. Kindly go through this and find this and do let me know in my chat box.